This is operations on function multiplication of binomials using the area model. First off, what does binomial mean? Binomial means two, meaning this is basically what this is talking about is when we're multiplying functions that have two terms. This is super important for you when you go into the 10th grade and Math Secondary 2. They spend the first half of the year almost on multiplying binomials to get you into quadratics and parabolas. So we wanted to make sure we hit this with you. So a really quick review. Mr. Nelson covered this last time, but I want to start off with reminding you about what the area model is. So here's a simple distribution problem. And in the past, you may have done this by just distributing the two using the arrow language, and you would multiply each number in there by 2. And then simplify that 2x plus 6, right? The area model simply takes the two things being multiplied. So we have 2, and we're multiplying it times x plus 3. And that creates 2 boxes, and so we know this should end up having 2 terms in it. And we multiply just like in school when you did a multiplication table. 2 times x, you would, wherever they meet, that's where the answer goes. So 2 times x. Well, x has an invisible coefficient, that's the creeper of 1. 1 times 2 is 2, and there's no other x, so it's just 2x. Over here, it's the 3 comes down and the 2 comes across, so 2 times 3 is 6. And because this is positive, we write a plus. This is the only time where you really, using the area model, you really have to put a positive sign and a negative sign just to keep track. At the end, we can add like terms, but there are none, so the answer to this is 2x plus 6. Now, I get that some of you guys could just do this and you're like happy to go lucky, but just remember we're setting this up so that we can do more difficult things. So one more example of that. Here's a slightly more difficult problem. We have 3x being multiplied by the binomial 2x plus 4. Again, I could do arrow language and do 3x times 2x plus 3x times 4, and then simplify that. 3 times 2 is 6, x times x is x squared, and 3 times 4 is 12, and bring the x. And so there is my answer. But really quickly to show the area model again, can I move that? Can I move that? I can't, so I won't. I could put the terms out front here. So if I erase that, get that out of your way. I'd put the 3x on the front, that's 1 term, and then 2x plus 4, that's 2 terms, and I'm multiplying them. Again, coefficients, 2 times 3 is 6, and then x times x is x squared that we learned in the last couple of videos. And then in the next one, we have 3x times 4. 3 times 4 is 12, and x. And again, we're going to put a plus sign in front of it just to sort of show that that's positive. And if there are any like terms, we could add them, but there's not. So the answer is 6x squared plus 12x. And so you're saying, Mr. Craig, Mr. Nelson, Ms. Johnson, why are you showing stuff that you've done before? Because that leads us to this. We have talked about multiplying functions before. So we've done f times g before, but this time we have function f, and function f is x plus 1, which is a binomial. And then we have function g, and function g is also a binomial. So this starts to get a little more difficult. So we look at this and we say, or maybe we don't, we say, oh, so f times g of x is f of x times g of x, and that ends up equaling x plus 1 times x plus 2. And this is not a simple distribution. So there is a way that you can do this, and it's using the area model. What we're going to do is we have 2 terms here, so we know, we have 2 terms here, 1, 2, so we know we have 2 terms, and we have 2 terms here, so we have 1, 2. So it ends up giving us a model that has 4 squares. Now, where you put those 2 terms doesn't matter. So what I mean by that is I can put x plus 1 here, or I could have put x plus 1 here. It doesn't matter. So for the purposes of this exercise, since I saw this one first, I'll put it in the front. So I'll say x plus 1. Notice I put a plus 1 there. I don't have to, but it's a good habit to get into, because if this had been x minus 1, I'd want to make sure I brought that minus sign down. And then the next one is x plus 2. And again, so you see that we have these we end up with these 4 boxes. Now the way we solve this, again, is just like before, with like we would with a multiplication table. There's a couple things I might want to add here. For instance, it might be nice to say that the coefficient of the x here is 1, and the coefficient of this x here is 1, just to remind me. Because when we multiply these, I say 1 times 1 is 1, which I really didn't need to write, and x times x is x squared. Going down the line, 1 times 1 is 1, and x. Then I come over to this box, I have x times 2. Well, there's 1 times 2 is 2, and there's just one x, so that goes there. I'm going to make a positive x, so we know where that's positive. And then we have 1 times 2 is 2, and we'll make that positive. So now we have something different than we've had in the past. We have 4 boxes that we want to see if there's like terms. So some people can just say, oh, Mr. Craig, I can see right off the bat that these boxes right here, and you will find that often, if you have your terms in order, diagonal boxes tend to be like terms. But if you don't see that, simply write from starting on the top left corner, working your way across, then go to the bottom corner, write them out. Go 1x squared, check, plus 2x, check, plus 1x, check, plus 2. And now I've written them from left to right and then from top to bottom. Now they're already pretty much in order, because the top left one tends to be the biggest one. So I don't need the 1 there anymore. I can just put x squared. I could leave a 1, I don't have to. But then I have 2x plus 1x is 3x's. And then I have a plus 2. So the solution to this is f times g of x equals x squared plus 3x plus 2. And again, to put it into Chromebook, you just put x caret key 2 plus 3x plus 2. This is multiplying binomials. Anybody want to add something to that before I go to the next slide?
Looks good.
Okay.
You're cool, Mr. Craig.
Okie dokie, we're moving on. So the next one we're looking at is, again, f times g of x. And so again, we're looking at multiplying a binomial, meaning 2 terms, times a binomial, 2 terms. But this time we added a negative in there just to sort of show you what happens. So we're going to start off by saying another way to write this is f of x times g of x. And then we can replace those with parentheses, and we can write it as 2x plus 3 times x minus 2. Again, I just write it, it doesn't matter where you put your terms. I can put these two. What I mean by that is I could put these 2 terms on the top, or I could put them on the side. It's up to you, as long as you keep them in order. But because I saw them first, I'll put them in the front. So I have 2x, and because I have to write this way, I can put plus 3. Now, I have noted that some people in the past have done this, and this is perfectly fine. They write their term sideways, 2x plus 3. Just so long as you can keep track of it, that's okay. Writing it sideways can sometimes be confusing, but if you see that I've written 2x plus 3, you can write this way or that way. Some people find this way easier just because it keeps everything lined up. And then on the top, I'm going to write x minus 2. This would be x minus 2. And then because I already have a coefficient there, I'm going to go ahead and add a coefficient here. It just helps me keep track of things. And again, to multiply these 2 together, we have the coefficient of 2 times 1, which is 2. And x times x is x squared. Then down the column, 1 times 3 is 3, and there's no other x, so it's just x. Then I go across, 2 times, be careful here, negative 2 is negative 4, and I have an x here. And then I have 3 times negative 2 is negative 6. And again, you'll note, because we have them in order, that the diagonals are like terms. But if you do not see that, then I would just write it out. Meaning you start in the top left corner, which is your 2x squared, work my way across, minus 4x, plus my 3x, and I could put a plus there if it helps, 3x, minus 6. And now you can see that I have an order. This is my biggest number, 2x squared. But I do have two like terms here, minus 4x plus 3x. Minus 4 plus 3 is negative 1. I could write a negative 1x, but do I have to write the negative 1x? No, I could also write this as 2x squared minus x. Because just like you don't say, Mom, Dad, please pass me 1 salt shaker. They look at you like you were crazy. You just tell them to pass the salt. Same thing with variables. You don't have to say 1x. I can see there's 1x there. You've written an x. So again, this top one here is not technically wrong. And if you write that on the test, it will not technically be wrong. But this is actually the more accurate way to write it. Remember to use the caret key if you're writing it into the computer. Anybody have a question on that one? For my crew, my peeps.
Do you need to write the relationship?
That is actually awesomely correctly true. Yes, you are right. I should have written in here, if I'm writing it on paper, I would definitely need to write down f times g of x equals. But on the test, it'll show you f times g of x equals, and then there'll be a box there to fill it in. So you won't have to do it on the test, but on your paper, you should always write the relationship. Because if you're in a relationship, you should tell people. All right, here we go. Now we have another one, f times g of x, which is kind of, again, if you've already gotten this, you can go ahead and try to do the activity. All we're doing for these is making them a little bit difficult, more difficult to sort of help you out here. So again, f times g of x, we have a binomial and a binomial. So you might have guessed what's going on here. We're going to rewrite this as f of x times g of x. And then we're going to rewrite that as x minus 3 times negative 3x plus 3. This one I'll write it sideways just to show you it doesn't matter. I can write this as x minus 3. See how I wrote it kind of sideways? Doesn't hurt it. Negative 3x plus 3. Some people like to write it that way because it's easier to keep track of everything. But I do like to add in the coefficients because that helps you keep track of what you're multiplying. So why I do that is so that when I'm multiplying, I could say in the first box, it's the coefficient 1 times negative 3, which is negative 3. And then x times x, that's going to give me x squared. In the second box here, I'm multiplying negative 3 times negative 3. Well, a negative times a negative is a positive 9. And then I have that x there, and so that brings it down. Then I come across here, 1 times 3 is 3. That's positive. And x times nothing else, it's just an x. And then down here I have negative 3 times 3, which is negative 9. And once again, because we put them in order, you'll see that the diagonals are like terms. So I could literally write the answer from here and just write down, oh, I see this is negative 3x squared, and 9x plus 3x is 12x, and then I have my minus 9, and you are perfectly okay to do that if you can jump ahead like that. But if you don't see it that well, then again, start in the top left corner and work from there. Negative 3x squared plus 3x plus 9x minus 9. And then you add your like terms, which would give us 12x. So hopefully that helps you out. Now there's one last scenario. This is a tricky one. And that's this one. That looks kind of weird. It just says y plus 5 squared. And I don't know if you remember this, but if the square's on the outside, it means that it's multiplying everything inside the parentheses twice. So people say, well, then shouldn't it just be y squared plus 25? And the answer is no. Because of that addition sign there, things get messed up. I'm going to keep this to the side so that we can talk about this, which is I know is a wrong answer. I'm going to keep this to the side so that later we can substitute a value in. We can talk about how different our answer is. What I'm showing is that because this is squared, I'm multiplying y plus 5 times y plus 5. I'm multiplying everything in there times itself twice. So because I'm multiplying a binomial times a binomial, that means I need a square box. And that means I'm going to be putting y plus 5 here. And I can write this sideways if I want to. Maybe it helps if I turn my paper that way, though. So some people will write it the same way, y plus 5. You don't have to write it that way, but some people find it easier to do that. And again, before I start, I'm going to add in my coefficients. There's an invisible coefficient here, an invisible coefficient there. It just helps you keep track of things. And the way we multiply is 1 times 1 is 1. Y times y is y squared. And 1 times 5 is 5, positive. And we have a y left. And over here we have 1 times 5, which is 5, and we have a y left. And then 5 times 5 is 25. And so now, again, you'll notice that my diagonals are like terms. And if you don't see that, don't worry about it. You just write the whole thing out. 1y squared plus 5y plus 5y plus 25. That's starting at the top left corner and working my way across, and then the next line down. And then I see I have 2 like terms. And do I need the 1? The answer is no, but I could if I wanted to. And 5y plus 5y is 10y's plus 25. So up here you got y squared plus 25, but the actual answer is y squared plus 10y plus 25. So if I put a value in for y, say I said y equals 2, up here you'd have 2, which is 2 squared is 4, 4 plus 25 is 29. But here, when I add in my 2, I would get 4 plus 20 plus 25, which is 49. Completely different answer. So it's very important that when you're writing this stuff down, that you pay attention to the rules of math, which means it should have been y squared plus 10y plus 25. So again, if you think you have this, you could go on and just go to the lesson and try it. If not, I'm giving you one more, this time with subtractions. Again, we have x minus 7 squared, which is the same as saying x minus 7 times x minus 7, which is a binomial times a binomial. That's x minus 7 times x minus 7. And before I start again, I'm going to put that coefficient in front of them, that invisible one. And again, I'm filling the boxes, and I'm going pretty fast, but I know that you can pause me and you can write it down, or you can go over it more than once. So 1 times 1 is 1, x times x is x squared. 1 times negative 7 is negative 7. I have the x still. 1 times negative 7 is negative 7. And I have the x still. And negative 7 times negative 7 is positive 49. And again, my diagonals, you see a pattern there. If stuff is in order, diagonals tend to be like terms. But if you don't see that, you just write down 1x squared minus 7x minus 7x plus 49 by starting up in the top left corner and working your way across row by row. And then I don't need the 1, so I can leave that alone. And then I have minus 7 is minus 14x plus 49. This should give you enough information to be able to do the activity. Please email us if you have any questions. Ms. Johnson, Mr. Nelson, do you have anything to add in?
Nope, just attend to precision. Make sure that all the things you're multiplying are where they belong.
Groovy. The coefficient thing really helps. I'm telling you, it can really, really help you keeping track of your coefficients and your variables. All right, that concludes this lesson. We have 2 more lessons left in this video, and then you're going to be going on to your summative. Woohoo!